Okay, the ideal gas law is a very versatile law that we can use when working with gases to calculate a variety of different properties. So the ideal gas law itself is pressure times volume equals the number of moles times the gas law constant times temperature. This varies from something like the combined gas law because there's no change in conditions. This law includes all four variables or properties that describe a gas. And the gas constant R, we're going to be using the 0.0821 liters times atmospheres moles times Kelvin. And the reason this is important is because the gas constant has that value with using those units. So in the gas law problems, we'll have to make sure that our volume is in liters, our pressure is in atmospheres, the amount needs to be in moles, and then the temperature will be in Kelvin. So I would like to use the ideal gas law to calculate molar mass. And there really are two different ways to approach this problem. I'll first tell you one that I think is a little bit simpler, and then I'll show you how you can substitute and use the ideal gas law. So here's the first way, and like always, when I am showing you two different ways, it's not that I want you to master both ways, but I want you to observe them, think about them, and see what makes the most sense for you so you can be successful. So we know that molar mass is equal to the grams divided by the moles. So when you are asked to calculate the molar mass, they will have to give you the grams. And we're going to read problem 10.71 in a minute, and it will give us the grams. So the first method would be to use the ideal gas law to solve for N in the ideal gas law, and then you could plug it directly into this equation I have here on the left. If you're given grams and you've solved for the number of moles, you can just divide the grams you were given by the number of moles. So let's take a look at 1071 and see how that would actually work. So it says a chemist isolated gas in a glass bulb with a volume of 255 milliliters. 255 milliliters. I know for the ideal gas law I have to use liters. So I move the decimal 3 places to the left. And a temperature of 25 degrees Celsius. So the temperature is 25 degrees Celsius and I have to work in Kelvin. And then it gives me a pressure of 10 torr. Now I'm going to have to use atmospheres. What I have found in this book is that if you want to get the same answer as the book, you cannot really round this atmosphere. So what I've been doing is just putting the actual conversion into the problem. When I tried to round, I ended up getting an incorrect answer. So I'll show you what I mean by just putting it directly into the problem. It just seems to give me an answer that's always right on, at least with their answers. So it's just a rounding thing. It also told me that the sample weighed 12.1 milligrams. Again, this is problem 10.71 in the back of the chapter 10. Now, in molar mass, it's grams, so I'll move the decimal 3 places to the left to convert milligrams to grams. Okay, so let's first, we know if I'm looking at this equation up here, I know that the molar mass equals grams by the number of moles. Well, I know the grams, they gave it to me, So now what I would like to do is calculate for the number of moles using the ideal gas law. So rearranging the ideal gas law, I get the number of moles would equal the pressure times the volume divided by RT. I just rearrange the ideal gas law. Now this is what I mean about the pressure. So I would put the 10 torr, and then right in the problem I would put the conversion. You don't have to do that, but if you do, this is times. If you don't, be sure not to round. If you're comparing to answers in the back of the book, if you're practicing, don't round when you get those answers, and you'll be better off. Okay, so then I multiplied that by volume, and then I get R, which I know is the gas constant. And then temperature, I plugged in at 298 Kelvin. And if you solve for this problem, you get 1.37 times 10 to the negative 4 moles. I want to keep it all on this page, okay? So I'm going to, oh, I don't have to. Never mind, it was going to be too crowded. So I know that the molar mass is equal to the grams divided by the moles. So the grams were given, so I'll now plug in the grams that were given. I just calculated on the previous page the number of moles for this particular sample. And if I divide the grams by the number of moles, I get that the molar mass of this gas was 88.3 grams per mole. Okay, so that's one way to solve. So you take, we know molar mass is grams per mole, so you take the grams that are given, you use the ideal gas law and the information that's given to calculate the number of moles, and then you take and divide the grams that were given by the number of moles you calculated, and that gives you the molar mass. Now the second way involves a rearranging of the ideal gas law. So I know that PV equals nRT, and I know that the molar mass, which they're asking me to find, equals grams over N. Whoops, sorry. Not G over G, grams over N, the number of moles. So if I rearrange that, I could rearrange, and that would tell me that the number of moles equals grams over the molar mass. So now I'm going to plug that in to the ideal gas law. And now I'm going to rearrange for M. So then if I brought M to the other side, M would equal grams RT over PV. So basically what I did is I rearranged this equation here. So I rearranged it. And then I substituted that, my rearranged number of moles, into the ideal gas law. And then I took this equation right here, after I substituted it, and rearranged it to equal here. So now I have where I can solve, and I suppose you could memorize that equation if you wanted, but now I would have where I would solve, plugging in the number of grams that they gave us. That was given. R is a constant. Temperature we had was 298 Kelvin. That was given. The pressure was 10 torr, but it has to be in atmospheres. So we convert by dividing by 760. And then the volume for this sample was 255 milliliters, so I have to put that in liters. And again, if you rearrange, now do all, I'm not rearrange, if you do all the math here, you get the same answer of 88.3 grams per mole. So again, this is two ways to accomplish the same, or to solve the same problem. You don't have to be experts at both. Take a look, see what makes the most sense to you, see what you're most successful at, and solve that problem.